All right, here we go again. Chapter 5, Section 6, talking about absolute value inequalities, only this time we're going to look at greater than inequalities. So, just like with less than inequalities, we have to use compounds, the intersections and unions, ands and ors, in order to solve absolute value inequalities. Last time we talked about less than using and. This time we're going to talk about greater using or. Notice the capitalization. Greater uses or. So, not a whole lot of discussion here. Let's just go ahead and dive into our first example. We have the absolute value of 2x plus 8 being greater than or equal to 6. Okay? And remember, when we had greater, we had two different equations, or two different inequalities. So the first scenario, the first inequality, is to keep it exactly the same, just drop the absolute value bars. So we'll say that 2x plus 8, excuse me, just got done eating lunch. 2x plus 8 is greater than or equal to 6. And we'll go ahead and solve that, just like we would normally. Subtract 8, so that 2x is greater than or equal to negative 2. Divide by 2, so that x is greater than or equal to negative 1. Okay? You'll notice I didn't flip my inequality because I didn't divide by a negative. I had a negative on top, not on bottom, so please don't get those confused. Okay? So there's one of our equations, or one of our inequalities. X is greater than or equal to 1. The second scenario is to flip the inequality sign and change the sign of our answer. So what I mean was we had 2x plus 8 is greater than or equal to 6. That means we're going to still have 2x plus 8, only this time we're going to have less than or equal to negative 6. Okay? So now we still subtract 8. 2x is less than or equal to negative 14. Divide by 2, x is less than or equal to negative 7. Okay? So there are your two inequalities. Remember, with ors, we couldn't put them together because the way that the inequalities worked. But if you solve them each separately, you get the two inequations, okay, or two inequalities. Okay? So those are your two answers. Now you're going to try one on your own. 2x plus 5 is greater than 7. So hit pause on the good old YouTube and see if you can solve this on your own. Then when you come back, we'll take a look at it together. All right. So the first is to keep it the same. 2x plus 5 is greater than or equal to 7. 4, we'll have 2x plus 5 is less than or equal to negative 7. Okay? One way that I remembered it, and the way that I was taught, was the little phrase, you're greater than the positive, less than the negative. Okay? So when you set the two up, you're bigger than or greater than the positive, less than the negative. So we set these two up, we solve them each separately, so that 2x is greater than or equal to 2. Divide by 2, x is greater than or equal to 1. Or if we solve this right side, 2x is less than or equal to negative 12. Divide by 2, x is less than or equal to negative 6. And there are your two solutions. Okay? Not too difficult. Again, absolute values are just about remembering which compound inequality is set up. So if you understand sections 2 and 3 with the compound inequalities, the intersections, and the unions, you should understand 5 and 6 because it's just getting to those compound inequalities. Okay? Now, unlike the less than absolute values, we can solve greater than with a negative. Okay? We can be bigger than a negative number. That's possible because 10 minus x, the absolute value, is going to be positive, and positive numbers are bigger than negative. Okay? So like I said, we can still set up the way that I talked about right at the beginning. Keep it exactly the same. 10 minus x is greater than negative 15. Okay, so we kept it the same, or we do inside the same, flip the sign, change the sign. Okay, so again, we'll solve here, and negative x is greater than negative 25. Divide, we have to get rid of that negative sign, so I divide by negative 1. What do I do when I divide by a negative, class? Flip the inequality sign. Good job, class. You guys sounded a pretty deep voice, too, for being middle schoolers. I'm impressed. So, x is less than 25. When I solve the other side, subtract 10, negative x is less than 5. Divide by negative 1 again. This time, let's see if the girls know what to do when I divide by a negative. You flipped the inequality sign, Mr. DeZorio. Good job, girls. So now x is greater than negative 5. And there's our answers. Okay? I hope this made sense. Like I said, after doing sections 2 and 3, this shouldn't be too difficult. You just have to remember when to do which compound inequality. At the bottom here, I have a nice little summary. When we have the absolute value equation, this number 1, when the absolute value of something is equal to something else, we do equal to the positive, equal to the negative. When the absolute value is less than a number, we use our and. And when the absolute value is greater, we use or. Okay? I hope this all makes sense. We'll be working on it in class, and we'll be seeing you guys soon. Bye.